In the previous video, we have seen climbing stairs problem. In this video, we will see Tower of Hanoi problem. So what you see here is an illustration of Tower of Hanoi. In Tower of Hanoi, we will have a rod and we will place multiple discs in the rod. So there is one rule to this. We cannot place larger discs on top of smaller discs. We should always place smaller discs on top of larger discs so that it looks like a tower. We can have as many number of disks as we want. There is no restriction on that. And coming to Tower of Hanoi problem, the problem here is to move all the disks from the first rod to the last rod using the intermediary rod. The few rules here: we can move only one disk at a time, and at any point we cannot place larger disk on top of the smaller disk, and we should achieve it in minimum moves. So let us go ahead and see one example. First, let us see how we can move two disks. We need the intermediary disk here. We cannot directly move this here to here. Then we will not be able to move the larger disk. First, we move this red disk to the intermediary disk. Then we move this larger disk to the last one. And finally, we move this red disk to the last rod. So as you can see, it involves three different steps. So to move two disks, we have to perform three steps. Next, let us see moving three disks. So how we can solve this is, first we can move this purple one to the last rod, then we can move this red one to the intermediary one, and this purple one we can move it to the second rod. Then we move this biggest disk to the last rod, then we move this purple to the first one, then the red will be moved to the last one, and finally this purple one will be moved to the last rod. So this involves 1 2 3 4 5 6 7 total steps. So how can we come up with the formula for this? So consider this is Tower of Hanoi problem with three disks. So what we have done is we have grouped this first three steps into one. If you observe carefully, what we are doing is we are moving this two disks to the intermediary disk. We are not touching this the last disk. Only these two disks we are moving to the intermediary step. So if we have n disks, we are moving n minus disks from rod A to rod B. In the next step, we are moving the largest disk from rod A to rod C. In the last three steps, the n minus 1 disks in rod B, we are moving it to rod C using rod A. So our formula for moving n disks from A to C using B will be moving n minus 1 disks from rod A to rod B plus moving one disk from rod A to rod C plus moving n minus 1 disks from rod B to rod C using rod A. So our base case will be, for moving one disk, we just need to move from source to destination. For two disks, we need to move the top disk to intermediary, then we need to move from source to destination, then we need to move from intermediary to the destination. Here in the first subset, our source is A, C is our intermediary, and B is the destination. So let us go ahead and print these moves using JavaScript.